Okay, class, so this is going to give you some information on how to complete the SPSS assignment. So go to Canvas, go to, I believe, week 13. Click on, make sure you click on the assignment. You should see like the data set, the instructions, links. I opened them in tabs, so it's easier for me to view them. Then you should get the instructions. It should look like that. Follow the instructions, launch SPSS. Once you open the data set, it should look like that as well. Okay, so just following the instructions. It looks like I'm trying to make some adjustments here on my screen. Give me a moment. Okay. Okay, so just trying to put them side by side here so you can see the instructions. So you want to go to Analyze. All right, go to Analyze, Compare Means. All right, so let me click on. So it says here, give me the instructions. You want to do a one sample t-test with a given data set. Go to Analyze. It's toward the top. Compare Means. One sample t-test. Select salary. Type in 25,000 as the test value, and then click OK. Okay, so this is what you're going to see when you generate the results. So on the top, you will see, remember, this is sample, this is just for demonstration purposes. Okay, these are not the actual values you're going to get. So you will see the sample size, which is n, the mean of the sample, the standard deviation of the sample. You will also get the t statistic. So please note that it's just a standardized difference between the two means. That's what the t statistic means. So, and to let you know, a t statistic value further from zero, the bigger it is from zero, it could be negative or positive, suggests your score significantly differs from the population mean. Okay, so the bigger it is, or the further away it is from zero, the more likely it will be significant. Here's the degrees of freedom. So it's essentially sample size minus 1. So these are very important. Okay, this tells you the probability of you getting this difference, the differences of mean, when you compare the population mean and the sample mean. Okay, so this is huge because this will tell you, and depending on your alpha, if it's significant or not. So pay very close attention, especially if it's a two-tailed, or in this case, two-sided hypothesis test. Take a look at that value. If that value, what you see where it says two-sided p, if that value is lower than your alpha, then it is statistically significant. Okay, so a low value p means significance in one-tailed tests for a specific direction and two-tailed for both. Okay, so it depends on your hypothesis testing process, if it's one-tailed or two-tailed. Lately in the class, we've been doing two-tailed, so focus on two-sided for now. Below, okay, so if it's below your alpha, if it's, let's say the common one is 0.05, if it's below 0.05, it is significant. If it is above it, it is not significant, statistically significant. This just tells you the mean differences between the sample mean and the population mean, depending where it is, but it's just a plain arithmetic difference. Okay, so this tells you, this is similar to the p-value, the significance p probability. So this is the 95% confidence interval of the difference indicates that, okay, so it indicates that the likely range of the average difference. All right, so one way to interpret this is that, the difference, like if there's minimal difference between the sample mean and population mean, it will likely have zero. Okay, zero in the range if there's little difference. But if this range, the lower and the upper, does not have zero in it, it likely suggests significance. Now, there's multiple ways of determining significance. Personally, the easier way is just looking at the two-sided P. That's just the simplest way. But, I mean, if you want to get more knowledge about this process, at least what these numbers mean, if you have zero in this range, that also suggests significance. But if it does have zero within that range, it suggests that it's not significant. And this is just the test value, whatever you want to compare, typically the population mean, whatever you want to compare it with. All right, so here's an animation of what happens when a population mean and a sample mean is either close to each other, meaning the difference is minimal, and when the difference is high. So right now, this illustrates that the population mean and the sample mean, the differences between those two means are minimal. They're small, relatively small. So that's what you're seeing here. If you look at the top, they're close to each other. They're probably, okay, so the sample mean is not in the region of rejection. All right. If you look at the two-sided P's, both of them are above 0.05. The t-value is close to zero. If you look toward the bottom right, look at the range. That range contains zero within that range. All right, now let's see what happens when the sample means and the population mean difference gets relatively larger. All right, so as you can see, the sample mean, let's say it's much lower, lands in the region of rejection. Look at the t-value. The t-value goes further away from zero. Look at the bottom left. The t-value goes further away from zero. Look at the significance p-values. They get lower. All right. As the mean value, as the sample mean and population mean gets, the difference gets larger, the p-values get lower. How much lower? Who knows? It could be, if it goes below the alpha level, whatever your alpha level you decide, then it is statistically significant. And look at the bottom right. Look at the range. The range looks like it's going away from zero as well, which means that the range will not contain zero. So what happens too is that sometimes the sample mean, since it's two-tailed, it could be either lower. I just showed you one end of the distribution, but it could also, the sample mean could be higher. It could be higher than the population mean. If that's the case, then it's going to be positive. So in that case, the t-value gets higher. All right, so it's further away. If you look at the bottom right, okay, so the sample mean gets larger. All right, so the bigger difference. Look at the t-value on the bottom left. So it goes further away from zero. It's more positive. So it's further away from zero, but it's on the positive side of the number line. The t-value, okay, the p-value, look at the significance in the middle, the arrows in the middle. They still go low. They still go low regardless. So no matter what direction it goes, like on the lower end or on the higher end, the p-values still go low. How low? I don't know. It depends on how big it is, the difference. And the confidence interval, it's going to go further away. On the bottom right, it's going to go further away from zero. And it may go the difference can go just enough that it will not contain zero in that range. So if it goes on the positive side, on the bigger side, then it lands in the region of rejection. And actually, if you look at the p-values in the middle, it may be just enough that it may be lower than 0.05. So how do you report this? Depending on your results. So here's the template on what to use to write up your result. The results of the one sample t-test. Okay, just copy whatever's in black, but whatever's in red needs to be filled in. So here, okay, the mean score of, and then, okay, so results of the one sample t-test showed that the mean score of the, okay, describe the sample. You could just sample, you could say the group or something like that. Just include the sample mean, okay? I provided that to you. The sample mean is in there. It's this part here. That's the sample. Okay, so a lot of the stuff that, or values you can get is listed there. All right, let me go back. Okay, sample mean, sample standard deviation. Okay, so depending on what results you get, it either was significantly different or was not significantly different. You have to state your alpha too. What alpha are you planning on using? 0.05, 0.1, 0.01? Okay, so depending on your alpha, it could be significant or not. But I suggest if you want to stick to the most common one, 0.05, you can't go wrong with that one. So if it's less than 0.05, the p-value is less than 0.05, it is significantly different. If it's higher than 0.05, and what I'm talking about are these. Okay, if the two-sided one is less than 0.05, it is significant. If it's higher than 0.05, it is not significant. That's what I'm talking about. Okay. And different from the test value of okay, so here you put the population mean, t, and then you put in parentheses degrees of freedom, equals, and then t value, you put the t statistic, and then p, and then put in brackets, depending if it is less than or more than 0.05. Okay, so depending on those values, if it's more, okay, remember, if it's more than 0.05, put greater than, use the greater than bracket. If it's less than 0.05, put the less than 0.05 bracket. Again, this will determine significance. If it's less than, put the less than if when it is significant, and put that bracket in there. If it's greater than and it's not significant, put the greater than bracket in there. It plays a huge difference. It will tell the reader if it's significant or not. All right, hopefully this was helpful. Good luck. See you in class.